it gives you a sequence.
You're right.
So,
It's
and it wants you to find the general term. And it's so I've got 1/5, and I know it's going to be one where I'm going to have like a negative something to an exponent in the bottom.
Yeah.
Because I'm seeing it go from negative to positive, and it's doing something weird in fraction land.
Right.
So I wrote the terms out. I had a big old list here.
Right. So this list I've got is mine. That should be the same list that you've got, right? That's the original. Okay. So what we're trying to do here is create the formula that would make this sequence on, right?
Yeah. So what I did is I went and I said like, oh man, 1/5 to -4/6. What do I multiply 1/5 by to get to -4/6?
Right. That's where you made the mistake. It's not that story. If it was a geometric series, that's exactly what you should be looking for. But this one is not a geometric series.
Oh.
So you by kind of hardwiring your brain to look that way, you were going down a rabbit hole, right? It wasn't ever going to get you anywhere, right?
Got it.
So what we're going to look at now then is what it is then, if it's not. And what I'm going to do here is I'm going to break this into 3 pieces. Let's take care of the plus minus thing, which you correctly identified. To make plus and minuses happen, you use -1 to the n, or you use -1 to the n plus 1. One of them is going to do it, right? So the first term should be +1/5. When n equals 2, it should be negative. When n equals 3, it should be back to positive, right? That's that alternating thing. So if I plug in 1 here, right? Do you see that -1 to the 1 gives me a negative answer? If I plug in 1 here,
n plus 1.
it's that. So that means I now have 1 of my 3 bits. And now I'm forgetting about the negatives. Don't matter now. They're accounted for. I'm now going to look at the bottom. And I see a pattern. And the pattern is that I'm adding 1 each time. 5 to 6 to 7 to 8. And if I'm adding 1 to each time, or 2 to each time, or 10 to each time, and that's called an arithmetic sequence, essentially, I can find its formula. If you add 2 each time, the formula is going to be 2n plus or minus something. But here we're adding 1 number, so it's going to be n plus or minus something, right? Because you're adding 1 each time, it's 1n. If you were adding 4 each time, it would start with a 4n, right?
So I think it's probably a 4, because if when n is 1, 1 plus 4 is 5.
That's that bit done now. And now I look at the top and I see 1, 4, 9, 16, 25.
3, 5. So we're going up 3, 5, 7.
7,
so
9.
We're going up by odd numbers. So right. 2n plus 1 probably?
No. I know where you're coming from, but what you're doing is you're making the rule for the difference. You're not making the rule for the original data. So when the numbers that you start with are going up by a fixed amount, that's when you do the n plus or minus something. But when the numbers are going up by 3, 5, 7, and 9, that is a pattern that you get with n squared. In fact, if you look at those numbers, aren't they just perfect squares?
They're perfect. Oh, so that should be probably n squared.
And it is. And there's your answer.
All right. I feel foolish, but I got it.
No, don't feel foolish. Your brain saw a pattern that you were hoping was geometric. Now, I could write down another sequence that technique of multiplying, by the same amount each time would have worked, in which case you probably would have got the correct formula. But not everything's a geometric series, even when sometimes they look like they might be.
I also wanted to say, which is great because now it's just me and you, Monday, I will be in class. Tuesday, Wednesday, Thursday, Friday, I won't be.
Well, yeah. Yeah.
And so I'll email you when we get closer to that. And then the week after that, I'll probably be there Monday. I don't think they will have us work Sunday. They normally, like, we're scheduled to do it, but they normally just chicken out.
Okay.
So
I'll
email you as I know.
Okay, so you're going to watch the videos, and once you've watched the videos, I'll ask you something about it, and that'll be the proof that you watched them.
Great. Perfect.
Great. No problem.
Yeah. I appreciate it very much. And my video is cutting in and out at the end of class. You mentioned something about the homework, and I got that we haven't done telescoping series, and so you said just do the
ones you can do. Right.
Does that count as taking an extension?
No, because that's me. What you'll notice once we finish this conversation, now that you've reminded me, what you will notice is that I will have moved the due date for that homework to next week.
Okay.
But I would still, what I'm saying is do those questions you can, so that you're not overloading your next week's homework. Because week one is typically always a bit lean, because I don't want to chuck you in the deep end, and we have all the other stuff, going over the syllabus and so on, that uses up time.
Yeah, I'm hoping next week. I know that next week I'll be able to. We have a guy who's got a master's degree in math, and he also works. We do certain. I fix cranes, and when we do certain things with cranes, where if the crane breaks, it'll be really bad. They bring us in to babysit the crane, and so I'm there on 12s to literally watch it in case it might break. So me and this guy who's a math major just sit down, and I do my homework, and he helps me sometimes.
Oh, it's nice to get. It's not a bad deal. It's nice to get paid to do your homework.
Yeah. There's also like a 3-day trip I might take, like December 15th, I think, but I'm pretty sure we're out of class by then.
I think we're out of class. We are. Anything after the 10th, we're out of class. So that'll be fun. Right. Okay.
Yeah. I appreciate you very much.
Not a problem. I'm fixing that. You can be my guinea pig. I'm going to fix the time that it's due, and give me a few seconds. And once I've said I've done it, I want you to go in to WebAssign and tell me that, that homework has now been moved to the 3rd. Okay, so there, save.
All right, give me 1 second.
Okay, I've done it. So you get in and check that homework has now been moved to the 6th.
I will check it in just a minute. I want to make sure that this problem will give me a, when sometimes it'll give you on WebAssign like hey, practice more of these. I want to see if number 13 will give me a practice more. Oh, it does. It has a practice another.
Right, so you can have a shot at doing your own after that, right?
Yeah, because otherwise I don't learn anything.
The right attitude. Yeah.
I'm paying a lot of. So I took your class before, and about 10 years ago, which is shocking. And
what? That I'm still here?
No, that it was 10 years ago. I can't believe I'm 30. So it now says that 11.3 is due Sunday, October 3rd.
Perfect. That's what I needed to see.
But I took your class 10 years ago, and I got out of high school and was like, oh, people don't take attendance? Oh, I don't really have to show up? Oh, I'm not going to. And that was not a formula for success. So I went back and I took pre-calculus, and I took all of them. And I also did a lot of trig on the outside, and it really worked.
Yeah.
So
I've always thought and this goes for me just like everyone else, that my old self could go back in time and tell my new self what would be a good idea. Because you definitely don't listen to anybody else, but maybe I would have listened to me.
Yeah, funny how your perspective on things changes in 10 years. I was just talking to somebody who's 10 years younger than me, and I'm like, well, there's some things.
Yeah. I did it that way, and now I'm back at college because I have to fix it. If I'd fixed it the first time, I wouldn't be doing it now.
Although there have been some benefits. I mean,
the
shipyard's paying for my school right now. I'm not even paying for this.
That's a good deal.
I pay for it in sweat and blood, but whatever. All right, you have a great weekend. I'm going to get to work on my homework.
Okay.
Thank you very much for the help.
Not a problem. Mia?